We can look at graphs of rational expressions. So some of you may or may not have done this before. So if you haven't done this, really focus on the factoring part. But really, factoring is important. So I'm going to first of all factor the numerator and denominator. So I'm going to get x plus 3, x plus 6 on the top, and x plus 5 and x plus 6 on the bottom. Okay, so I cannot divide by 0, so I have to state my restrictions. X cannot be equal to negative 5, okay, and x cannot be equal to negative 6. So I can also simplify this out. Okay, so if I have this expression x plus 6 divided by x, well, that's really just 1. Now, although I still can't make it equal to negative 6 because I have a 0 over 0 that I'm dealing with here. But the rest of the expression, apart from being at negative 6, is perfectly fine. Okay, so that's what it looks like. So what happens at the restrictions? Okay, so at x equals negative 5, we get something called a vertical asymptote. So negative 5, so this is the first time you've seen it. That's okay. We'll be doing more of this later. Okay, so there's my vertical asymptote. Okay, so this means I cannot have an x value at negative 5. And then I can actually start plotting some points to figure what this looks like. Okay, so I'm going to do something called a horizontal asymptote as well. And that happens when x gets really, really big. When x is really, really big, this number plus 3, really, the 3 really is insignificant compared to the x here. Same with the plus 5. So it tends to behave like x over x, which is 1. So I get this horizontal asymptote at y equals 1. So what happens is, as x gets big, the plus 3 and the plus 5 have very little effect on the ratio. And so it tends towards equaling 1. Okay? We also know that when the numerator is equal to 0, the whole equation is equal to 0. So at x equals negative 3, we know it crosses the x-axis. Okay, there's a solution to x equals negative 3 here. So what we're going to then do here is we're going to sketch this graph. So we're going to graph it through here like this. Okay, now we could graph some more coordinates if we're not sure. I can make a table of values and see what this looks like. Okay, but one thing that we have to be worried about is negative 6. Okay, so negative 6, there is an unknown value, okay, or undefined value. But other than that, we're okay. So at negative 7, if I put negative 7 into here, I get negative 4 divided by negative 2. That's going to be positive 2. So negative 7, positive 2. Okay, so it's going to be here. And I could plug in a whole bunch of points, but basically it's going to follow this asymptote, go through here. Now, I have to make sure that I don't actually go through the negative 6 because there's an undefined value there, but it will just kind of go through that point, but we just leave what we call a hole in there. Okay, so this is a hole, and this is a vertical asymptote. Okay, so this is something that, if you've not done this before, we're going to do some more of this later on. Okay, so there we go. That's what my graph looks like. And if you want to graph it on your graphing tool, and again, if you haven't seen these graphs before, it's a good idea to graph these on your graphing tool just to see what they look like. So this one here is solving rational equations. We're just going to solve this. To solve this, we first need to make sure that we state our restrictions. So x can't equal positive 6, okay, because if x is equal to 6, we're dividing by 0, and we can't divide by 0. Okay, so once I've established I don't want to divide by this, I don't even want to divide at all. I don't like these fractions. I'm just going to get rid of the denominator by multiplying by the common denominator. Okay, so I'm going to take that, just move that over a little bit. Okay? And once I get rid of that common denominator, my equation actually is very simple to deal with. I end up with x equals 3. Okay, so my solution for this is x equals 3. Just double check with my restriction. Yeah, it's not part of my restriction, so that solution is perfectly okay. X equals 3.